Howdy, this is your friendly neighborhood physics teacher here, and this is video 3 of your spring final review videos. This is going over 2D motion in general, so projectiles in the horizontal and projectiles in the angle. Again, this is video 3, so if you've missed torque and momentum, please go back and watch those. In the video, torque kind of goes about what to expect about the final as a whole. Let's get started. So again, this is the part of your review that's at the beginning. We're going to talk about variables, units, and equations. Now remember, the variables is what's in the equation, units is what goes after the number. So t, time, is represented by a lowercase t. Unit is seconds. Horizontal distance. Distance is represented with an x in that and horizontal in the x direction. So if you think about your graph, that is your x-axis, that's in the horizontal, and it's measured in meters. It does have its very own equation. So your change in your horizontal distance equals, that's another way of saying displacement, equals your velocity in the x times your time. Vertical distance, which is your y, think about your y-axis, that's measured in meters. So your equation for your vertical distance is your delta y equals VIY times t plus 1/2 AG t squared. Those are times between there. So there's your equation for that. Horizontal velocity, Vx, that's measured in meters per second. The equation for that just is the same as same equation, just manipulated. So you have your Vx equals delta x over t, and that's kind of looking at your units. Delta x is measured in meters, t is in seconds, so it's meters per second. So that's where the unit comes from, is the equation. Initial vertical velocity. So your initial vertical velocity is your VIY. That's in meters per second. And there isn't an equation for that one, so I don't know why. I mean, you can sit there and manipulate, but there's not really a known equation for that one, so you don't necessarily have to worry about that. So I don't know why that one's highlighted. And then your final vertical velocity, so you just be final y, still measured in meters per second. And there's actually two equations for your final vertical velocity. Your first one is your VYF or your VFY. Really doesn't matter which way, but we want to stay consistent. So your VFY equals your VIY plus AG times T. And then your another equation is your VFY squared equals your VIY squared plus 2AG delta y. So those are your two equations for your final velocity. Acceleration due to gravity is represented with an AG. That is a constant, so it's a negative 9.8 meters per second squared. Make sure you put the negative. Initial velocity is just represented with a VI, and that is in meters per second. Angle is represented with a theta, and there's no really, your unit would be a degrees, so it would be degrees, or in that case, just little zero. Now, dealing with angle, you do have some equations that go with angle. This is where sine, cosine, and tangent come into play. So your sine of theta is your opposite over hypotenuse, not adjacent, opposite over hypotenuse. be your adjacent over hypotenuse, and then opposite over adjacent. So there we go. So those are your equations using an angle. Now, a couple of other things that you might need to know, remember, is your Pythagorean theorem equation. So you have a squared plus b squared equals c squared. And when you have a right triangle, that only works with a right triangle. So that just means it's 90 degrees. And if your angle is over there, then this becomes your, so just kind of, that becomes your opposite, that becomes your adjacent, and that is always your hypotenuse. And then you can also, it doesn't matter which one you make, a or b squared. So we'll just make this a, b, c. So there we go. Kind of helping you with your triangle there. So your horizontal projectile has some just good information to know. So horizontal projectile means your projectile is going originally off horizontal, and then so like for that split second, it's just moving in the x direction, and then gravity finally, it's like, oh wait, something fell, and it starts getting pulled down. And it's getting pulled down at a rate of negative 9.8 meters per second squared. That is your acceleration due to gravity. That is always constant. That is always going down. That's why it's negative. Now, your initial vertical velocity is 0 because at the beginning, it's just traveling in the velocity in the x. And your velocity x is constant. Your velocity x is constant. So no matter where you are on this, your velocity x is going to stay the same number. And since your velocity x is constant, your acceleration in the x is 0. Your acceleration in the x is 0 because it's constant. Of course, to get some information, this would be your delta y. This would be your delta x. I think that's about it dealing with horizontal projectiles. So let's do a practice problem. So if you throw a pumpkin at horizontally off a cliff, so you're throwing it horizontally off the cliff, so that right there is telling you it's a horizontal projectile with a velocity of, velocity of 10 meters per second. And the pumpkin lands 50 meters from the base of the cliff. How long was the pumpkin in the air? So let's write down our givens. So you always know that acceleration due to gravity is negative 9.8 meters per second squared. It's being thrown horizontally off the cliff, so your velocity in the x is 10 meters per second. And since it's being launched horizontally, you know your initial velocity in the y is 0. And it says it's 50 meters from the base. 50 meters from the base. That is telling you that it's in the x direction. So your delta x is 50 meters. So what you're looking for is your time. That's what you're looking for. You're looking for your time, which is going to be in seconds. So that's when you sit there and figure out what your givens and and what equation you can use. So you're looking for time. You have your velocity in the x and you have your distance in the x. So the equation you're going to end up using is your delta x equals vx times t. So your delta x was 50, your v of x was 10, and you're looking for time. You want t by itself, so you need to get 10 over there. It's being multiplied. The opposite of multiply is divide. What you do to one side, you have to do to the other. So then you plug that into your handy dandy calculator and you see that you get 5 seconds. So it takes 5 seconds for it to be launched off. Now, again, you had some extra information. You didn't need to use that, and you didn't need to use that. But there's nothing wrong with you go ahead and writing it down as givens. You just didn't need them. So what is always constant in both x and y direction? And the key thing there is always constant in both. What is always constant in both directions? So x and y. So let's go up here and see here. So we're looking at our VIY. So that only stays 0 at the top. It starts increasing as it's going down. So that's not constant. Our Vx is constant, but that's velocity in the x, but we just said that our velocity in the y is not constant, so it's not velocity. Our delta y changes, our delta x changes, that's not constant. But our acceleration due to gravity, which is in the y direction, is constant. Our acceleration in the x direction is 0, but that's still constant. So the answer to this would be acceleration. Acceleration is the only thing that's constant both in the x and in the y. It's the only one that's constant in the x and the y. Okay. So dealing with angular projectile. Angular projectile does a full parabola. Angular projectile does a full parabola. And it's called angular projectile because it's being shot out at an angle. So anytime you have an angle, you know that you're going to need to draw a right triangle. Need to draw a right triangle. I'll redraw my little thing here. Okay. So this is our VI. This becomes our Vx. This becomes our VIY. So a couple of things to remember are VIY decreases. Nope, not the one I wanted. It decreases as it goes up until it eventually reaches the very tippy top, and your Vy at the top is 0 meters per second. And then as it goes down, your V, not Vi, just your Vy, your Vy increases. Now it's increasing and decreasing at the exact same rate. It's doing that at negative 9.8 meters per second squared. So the reason it's doing that at that rate, because think about it, it's negative, it's pulling it down, so it's decreasing until it reaches to 0, and then going down, it's going the same direction, so it's increasing. So that being said, whatever your VI is, it's going to be the same, VIY is going to be the same for your VFY. So your VFY is going to be the same, it's just going to be negative. So the same number, different direction. VIY is going to be positive, your VFY is going to be negative. Now your Vx, again, is constant. Your Vx is constant. And since it's constant, that means your acceleration in the x direction is 0 because it's not changing. your y is changing. That's why your acceleration in the y direction is negative 9.8. You have your delta y halfway. Your delta y is halfway. And then that would be your delta x. Maybe I should have used a different color. We're going to use a different color for that one. So that would be your delta x. Now remember, for your delta y, you need to use half time. And because it happens halfway. Think that is about it for overarching concepts. If I think any more, we'll scroll back up. So let's do some practice problems. So an archer shot an arrow with an initial velocity of 22 meters per second at an angle of 70 degrees. The diagram shows the path of an arrow. What is the horizontal velocity of the arrow when it reaches point 3? So let's do our givens. So our givens, it gave us that our initial velocity didn't give us a direction. So our initial velocity is 22 meters per second. Our angle is 70 degrees. And then it's asking for our unknown to be the horizontal velocity. We know that's going to be in meters per second. So we're going to have to draw a triangle for this one. So we're going to have to draw a triangle. That is our angle, which is 70, and our initial is 22. This is our velocity in the x. This is our initial velocity in the y. Another way to look at it is that's our hypotenuse. This is our adjacent. This is our opposite. So we're looking for our velocity in x, so that means we're looking for our adjacent. That means we're going to be using cosine, because that's adjacent over hypotenuse. Cosine of 70 equals adjacent, that's what we're looking for, over our hypotenuse, which is 22. We need our v of x by itself, so it's being divided. The opposite of divide is multiply. What we do to one side, we have to do the other. That cancels out. So we get our Vx is 22 cosine of 70. Now again, we're not going to have enough graphing calculators per kid, per student. So this one, I would definitely raise your hand and get a graphing calculator. The first thing you need to do is make sure it's in degrees mode. First thing you do is make sure it's in degrees mode. So to do that, you're going to hit mode, which is next to the second. You're going to scroll. It should be the third one. You'll see radians and degrees. You want degrees to be highlighted. You're going to move it over, hit degrees, and then you're going to hit second mode again and get out of that. And then you're just going to type in 22 times cosine of 70. Make sure you end your parentheses. And you should get that your velocity in the x is 7.52 meters per second. There you go. And 4. What is always constant in both x and y directions? Let's go back here. So it already states that our velocity, because we know our velocity in the x is constant, but our velocity in the y isn't, because it's decreasing and then increasing, so it's not velocity. Distance, it gets taller and then it gets smaller and then it's constantly getting bigger. So that's not a delta x or delta y, so our distance is not constant. The only thing that's both constant in the x and y is acceleration. Acceleration in the x is 0. It's not changing. And then our velocity, or acceleration in the y is negative 9.8. So again, the exact answer to this one is acceleration. It's the only one that's in both because the key thing there is always and then both. Acceleration is the only one that's always in X and Y direction. Number 5. A volleyball is thrown directly upward at a velocity of 5 meters per second. How long does a volleyball take to reach maximum height? So let's write down our let's first. So we have upward velocity. So let's write down our givens. So we always, since it's in vertical, we know that our acceleration due to gravity is negative 9.8 meters per second squared. It says that we have it's thrown upwards, so we know that our initial velocity in the y is 5 meters per second. How long does it take to max height? Now, what's so special about velocity at max height? We know it goes to 0. So we know that our VFY is 0 meters per second. Give me that. We know that max height is 0 meters per second. Our unknown, what we're looking for, is how long. So that would be our time. So we're looking for time, which in seconds. So equation-wise, so the only equation that has all of those would be your VFY equals your VIY plus AG times T. VFY is 0, VIY is 5, AG is negative 9.8 times T. So now, here is where algebra comes into play. I know you took your algebra exam, or you will take your algebra exam on Tuesday. So you can't just go fleshing the information just quite yet. You still need algebra. Or you took it last year. You still need your algebra. You have to think about. So you can't add these or subtract these because of that guy right there. They're attached. So you need to move the 5 over. It's being added, so the opposite of add is subtract. What you do to one side, you got to do the other. So that gives you a negative 5 equals negative 9.8 times t. We need the t by itself, so it's multiplying. The opposite of multiply is divide, and that cancels. So now you plug into your handy-dandy calculator. Negative 5 divided by negative 9.8. So it takes 0.51 seconds. Take 0.51 seconds for the ball to get to max height. Now it's asking for what is the volleyball's maximum height? What is the volleyball's maximum height? Get a little bit more room here. So again, the givens are the same. So let's write out our givens. So we still know that acceleration due to gravity is negative 9.8 meters per second squared. The initial velocity is 5. And since it's asking for max height, we know that the final velocity in the y is 0 meters per second. I do know we know the time yet, but just in case we didn't get it wrong, but I'm thinking like test-wise. So just in case you might have plugged in something funky, let's hold off on using the time. Let's just use these givens and see if we can figure out just by using these givens. And we're looking for our delta y. So the equation that you can use for that is that VFY squared equals VIY squared plus 2AG delta y. So let's plug in what we got. So we got 0, 5, negative 9.8 delta y. So we have to think about PEMDAS. We got to square it first. So 0 squared is just 0. 5 squared is 25. Plus, if you want to go ahead and multiply that out, so 2 times negative 9.8 would give you a negative 19.6 delta y. Now again, you can't just add or subtract those because of that sucker right there. They're attached. So you have to subtract both sides by 25. Need some more space. Space. I always write bigger than I think it is, but that's okay. So that cancels out. So you get a negative 25 equals a negative 19.6 delta y. They're being multiplied. The opposite of multiply is divide. What you do to one side, you got to do to the other. So you just plug that into your handy dandy calculator. So negative 25 divided by negative 19.6. And you get a 1.28 if you round meters. So it goes up 1 meter and 28 centimeters, basically. So there we go. So that is the maximum height the volleyball goes. Next question. So I will give you my lovely singing voice for this one. On top of spaghetti, all covered with cheese, I lost my poor meatball when somebody sneezed. It rolled off the table and onto the floor. The table is 1.5 meters tall, and it took 0.2 seconds for the meatball to hit the ground, and then it rolled 0.45 meters from the table. And what was the horizontal velocity of the meatball before it rolled out the door? Yay! So hopefully you actually knew that song. It was a kid's song when I was growing up. So I was having a little bit too much fun making this. I was thinking of a practice problem, and I started singing that in my head. And that should not surprise any of y'all. But my lovely singing voice now, I know you're wondering why I didn't go off and become an opera singer. It's just keep wondering. But okay, so let's do some practice problems, shall we? So some of the givens we have, it says the table was 1.5 meters tall, and it took 2.2 seconds for the meatball to hit the ground, and it rolled 0.45 from the table before it went out the door. And we're looking for our horizontal velocity. So a few givens. So we know that acceleration due to gravity is always negative 9.8 meters per second squared. That's a given, always a given. So it rolled off the table. So since it's rolling off the table, we also know that our initial velocity in the y is going to be 0. Our table is 1.5 meters tall, so that is our delta y. Seconds is time, so we know our time is 0.2 seconds. And it says from the table, so that's going to be our delta x is 0.45 meters. And our unknown, what we're looking for our velocity in the x, and that's going to be in meters. So if we look at it, we have our distance in the x, and we have our time. So our equation is just going to be delta x equals vx times t. Again, we have extra information. And it's okay. It's okay we have extra information. So our delta x is 0.45. We're looking for our velocity, and our time is 0.2 seconds. We want our velocity in the x by itself. They're being multiplied. The opposite of multiply is divide. What you do to one side, you got to do the others. Those end up canceling out, and so you end up getting that your velocity in the x is 0.45 divided by 0.2. You just plug that into your handy dandy calculator, and that meatball was booking it because it was going 2.25 meters per second. That was a very violent sneeze. I hope that person is okay. But that is our velocity in the x. So the next one and last one, it looks like a basketball is projected at an angle of 20 degrees above the horizon with a velocity of 12 meters per second. What is the approximately horizontal range across a level surface? So let's write out our givens. So we know that acceleration due to gravity is always negative 9.8 meters per second squared. We have an angle of 20 degrees, and we have a velocity. It doesn't say in which direction, so we know that is our initial velocity of 12 meters per second, and our unknown is our horizontal range, and that's going to be in meters. So we have a velocity at an angle. The first thing we need to do is break it down into its x and y components. So our angle is 20 degrees, and we know that is 12. So that becomes our velocity in the x. That becomes our initial velocity in the y. Another thing it becomes, we know that's hypotenuse, adjacent, opposite. So we need, let's go ahead, because I know we definitely need our velocity in the x, but we need our time also. So let's go ahead and so we need to do both basically. So we need to do sine and cosine. So sine theta equals opposite over hypotenuse. So sine 20 equals our opposite, which is VIY, over adjacent or over hypotenuse, which is 12. That's being divided. The opposite of divide is multiply because we need our VIY by itself. Oh, there goes meatball. And so that's 12 times sine of 20 equals VIY. And we just plug it in. Again, make sure your calculator's in degrees. Calculator needs to be in degrees. Again, to check that, you're going to hit the mode button, which is right next to the second. You're going to scroll down to the third. You're going to make sure degrees is highlighted. So you just scroll over, click on it with the enter button, and you'll hit second mode again to get out of it. And you're going to hit 12 times sine 20, make sure the 20 is in the parentheses, close parentheses, equals, and you get your VIY to be 4.10 meters per second. There we go. So now we're going to do cosine. Cosine of theta is adjacent over hypotenuse. We have theta is 20. Adjacent is the Vx like you're looking for, and your hypotenuse is 12. We need the Vx by itself. It's being divided. Opposite divide is multiply. What you do to one side, you gotta do to the other. And so you get your Vx is 12 times cosine of 20. Since you've already checked for the sine, you don't have to check again. But if you want to, I highly encourage you to. And so you get your velocity in the x to be 11.28 if you round meters per second. So we have our initial velocity in the y, and we have our velocity in the x. Since our equation for velocity in the x is v times time, we're looking for our velocity in the x. We just solved for our we're looking for our delta x. We just solved for our velocity in the x, so we still need time. So let's see, what equation can we use for time? So for a projectile, to get the whole entire time, you need to do whoop. So we just solved for our initial velocity in the y. What's so special about our velocity in our final velocity in the y? Hopefully, you're saying that your initial velocity in the y is the same as your final velocity in the y. It's just negative. So if our initial velocity is 4.1, that means our final velocity is going to be negative 4.1 meters per second. And that being said, that means we can use our VFY equals our VIY plus AGT. Because we know our final velocity, which is the negative version of our initial velocity. And we know that acceleration due to gravity is negative 9.8. Now, we need RT by itself, but we can't add or subtract right here because it's attached. So we need to subtract, because it's being added, subtract this from both sides. So then you plug in to your handy dandy calculator negative 4.1 minus 4.1, and you get a negative 8.2. Yay! Equals a negative 9.8 t. And t by itself is being multiplied. The opposite of multiply is divide. What we do to one side, we got to do the other. Those end up canceling out. So our t just ends up equaling negative 8.2 divided by negative 9.8. You just plug that into your handy dandy calculator. And you get that it took 0.84, if you round, seconds for it to go to do the projectile all the way. So now we have time. There we go. So we're looking for our delta x. Our Vx is 11.28. Our time is 0.84. You just plug that in your handy dandy calculator to multiply. So 11.28 times 0.84. And you get a 9.48, if you round, meters. So there we go. If you have any questions, please let Miss Heath or Miss Verona know. Happy studying. You have about 4 more videos left, and you had about 2 videos before this one. So make sure you catch them all. Bye.